Greetings and welcome, friends. Mr. Waddy here. I'm on page 151. Perhaps you are there with me. And we were talking about transformations of graphs of linear functions. And this is section 3.6 from your Big Ideas Algebra 1 book. So it says this: use the graphs of f and g to describe the transformation from the graph of f to the graph of g. So here's the graph of f of x. Let's see, question, just as review. For f of x, what is the slope of f for this guy? What's that slope? Yeah. -2, the number in front of the x. Trickier question, perhaps. What is the y-intercept? Ooh. It's actually 0 because there's no number being, right? Y equals mx plus b. The plus b didn't exist, so b was 0. And also notice that it did happen to cross through the origin right there. So now if I take the function f of x and add 2 after I do the multiply by -2, what type of transformation does that? How does this red line relate to the black line? You're absolutely right. They are parallel to each other. Specifically, what do you think this +2 on the outside of the function does graphically? It shifted it up 2 units, right? So it was a vertical shift up 2. Wow, I'm getting a lag today. I have too many things open? No, I shouldn't. A little bit of lag. That's okay. We'll keep going. Yeah, but this is all running locally on my own machine. Question 7. So I skipped ahead a few. I said it was a vertical shift up 2. Was the answer to that question. Let's see. Here's question 7. Let's graph the original. What is the slope of this guy? 1/3. So that means it'll go up 1 over 3. And what is the y-intercept? That is 3. So to graph this, we begin at 3, right? And the slope is 1/3. So I move. Rise over run, so up 1 over 3, right? And I could get a couple more points if I wanted. Up 1 over 3, up 1 over 3. Or I could even go down 1 backwards 3, because 1/3 is the same as -1 over -3. And when I draw that line, let's see, I'm used to drawing it in the purple here. Looks like something like this would be my equation. So now the question is, function g of x, all right, because this was f of x, what happens if I subtract 3 to those outputs, to everything that I got out from f? What is that going to do to the function g of x? And so which way is that going to move it? Is it going to move up, down, left, or right 3 units? Well, the -3 is on the outside of the parentheses, so it's changing the outputs, which is the y, right? So it's changing the y by moving it down 3. Here's my y-axis. Here's the negative y-axis, so changing the y by 3, it's going to actually shift it down 3. So this point is down 3, this point is down 3, this point is down 3, and I can just kind of move. Man, I feel like I'm drawing crooked here. Whatever. That point is down 3, and conveniently, this line, as Tyler said earlier, is parallel. It's just been shifted down 3 units. So this was a vertical shift down 3. Right? And what we describe that as, if you have some function g of x is equal to another function, some parent function perhaps, plus k, on the outside, we said that if k is negative, it's a shift down, and if k is positive, it's a shift up, right? So that's kind of like the property that we talked about, barely talked about yesterday, right? I realize we didn't get to spend a lot of time on that. We'll have more time today, though, friends. Don't you worry. I know you've been up all night hoping that I was going to post part 2 of that video, but it is in the future still. So I have a hard time posting videos from the future. I think YouTube isn't cool with it either. So let's see. M, what's the slope of my original line? Yeah, 1/2. So that's going to mean up 1 over 2, up 1 over 2. What's the y-intercept? More specifically, the -5. All right, so that minus sign is included in that. So to graph it, I would go down 5 right here. You got it. Yeah, you guys are slope experts now. Up 1 over 2, up 1 and oh, I went over too far. Up 1 and over 2. There's some points. And you could also have pretended this is the same as -1 over -2. So if you, for some reason, ran out of space, you could go down 1, backwards 2. And that lands on the same line. Let's draw that line. It's steeper than our up 1 over 3 line, notice. The current ruler is set to the up 1 over 3. So up 1 over 2 is steeper. I don't know if you guys spotted that. So there's my, oh, wait, I always use, here we go. My bad. Get your colors straight, Mr. Waddy. All right, so there's the original line. Now this is tricky. This is f of x minus 3. But minus 3 is happening to the x before it gets plugged in to the function. So I'm subtracting 3 from the inputs. And this one was weird. It kind of was the opposite of what I would expect. So it's affecting the x's, right? The inputs are the x's. And so here's the x-axis. The positive x-axis is here. The negative is there. Which way do you think this will move it? Well, x is horizontal. This is affecting the horizontal variable. So is it, you think, left or right? Now, left, I would agree, is the best guess because I see a negative number and a negative number. But this is what's weird. It actually shifts it the opposite direction. For this one, it's opposite. For the y, it's the same. Right here, when I subtract 3, it moved towards the negative for the y. When I added 3 up here, added 2 on the outside of the parentheses, it moved towards the positive. It made sense for the y's, but for the x's, it behaves the opposite. Yeah, it's going to go right by 3 units. So at least the number makes sense. It's just weird that it goes in that direction. So this point is over 3, and this point is over 3, and so all of these points are going to shift over 3 units. There's a point that I didn't even know existed that's being shifted over 3. And so the original line is here, and now the new line cinema, Lord of the Rings trilogy, is right there, shifted horizontally over 3 units. Now I just want to make some claim for that. So here's f of x. That was equal to 1/2 x minus 5, right? And if g of x is equal to f of x minus 3, that means I'm replacing the x. Check this. Actually, I'll use purple. That means I'm plugging x minus 3 in for x. This is a little weird, but watch what happens. 1/2 of x minus 3 and then minus 5. I would have to distribute this. So that would be 1/2 x, and what's half of -3? Well, we would call that -3/2. I realize we haven't done a lot of fraction work yet. -3/2 combined with a -5. I could put the 5 over 1. Does anyone know how to combine fractions? It's tricky. You got to get a common denominator. So between 1 and 2, what's common between them? What's a number that both of those go into? Yeah, so here's the current denominators. 2 goes into 2, and 1 can fit into 2. So my least common denominator is going to be 2. This one's all set. But what could I multiply 1 by to get that 2? 1 times what is 2? 1 times 2. And if I'm going to multiply the denominator by 2, I'd also have to multiply the top by 2. So let's see. Okay, here we go. Equals 1/2 x minus 3 halves minus 5 times 2 is 10 halves. So that's going to equal 1/2 x. Negative 3 minus 10 is negative 13 halves. So here's my g of x function. I also could have thought of that as g of x equals, this will probably make more sense, 1/2 x. 13 halves, if I want to write that as a mixed number, 2 goes into 13, well, it goes into 12 6 times with 1/2 left over. And notice, where does this y-intercept appear to be? 1, 2, 3, 4, 5, 6 and a half. Okay, so if I was to plug in x minus 3 in for x and simplify it, which was a lot of work in this case, I realize, I would have gotten this orange line. All right, I would have gotten this orange line. So another way to think about this is subtracting 3 from the x, is to think about where was 0 for the x originally. So 0 for the x, for the original function, 0 occurred when x was 0, and my y-intercept was at negative 5. Okay, my new 0 is going to occur whenever, let me ask this question, let me phrase it this way. When is x minus 3 equal to 0? And for what value of x would x minus 3 equal 0? Yeah, I would add 3 to both sides, and I would get when x equals 3. So if you wanted to pretend as though I was graphing this, my old y-axis occurred here, right? Like so. My new y-axis occurs over here. So kind of, like if you want to think about it this way, that my, when is x minus 3 equals 0, when will my y-intercept be negative 5? It hits negative 5 right here for the y value, and that occurs for the new x value when x is equal to 3. All right, you don't have to like imagine any of that. I was just trying to give one other reason why is there this horizontal shift of positive 3 when I was subtracting 3. And it's kind of because of this idea right here. It's asking the question, when will x minus 3 equal 0 when x is positive 3? And that's why it's moving to the right. It takes a little while. The easiest way for me is just to remember, for horizontal transformations, you move in the opposite direction that you would think. So I'm going to write opposite. That's how I remember for horizontal. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.